Okay, Physics Part 1, Worksheet 2. We're on Problem 1 on page 1, and we have a skydiver jumps out of a plane, and we're looking at the speed due to the acceleration of gravity. That's what gravity does. It accelerates things. He or she is going to be moving faster and faster and faster in a downward direction as time elapses. So, first of all, we're talking about gravity. Gravity accelerates things down. We're only really talking about the speed going straight down, and basically at some time zero, the speed is zero. So the skydiver is not yet falling. He or she has basically just stepped off the plane and for a moment just kind of hangs there before they start falling. Almost instantly they're going to start falling, but this is the moment at which they are not falling yet. We'll call that time zero. So we have the acceleration of gravity, known as little g, is 9.8 meters per second squared. So I think we'll maybe just round that number to 10, right? And it's 10 meters per second, but it's per second squared. It's 10 meters per second, right? So every second, the skydiver is going to be going 10 meters per second faster, right? So they were initially at 0 seconds going at a speed of 0. After 1 second, they've accelerated by 10 meters per second. The speed is now 10 meters per second. And now another second passes. It's 2 seconds later. The person has accelerated by yet another 10 meters per second. Now the speed is 20 meters per second. Another second passes, they're going 10 meters per second faster. After 3 seconds, they're moving at about 30 meters per second, right? After another second, they're moving at 40 meters per second, right? And every second, they've gotten 10 meters per second faster. After 5 seconds, the skydiver is moving at 50 meters per second. So again, we've rounded the g of 9.8 to 10. You're welcome to use the value of 9.8, put it in to a calculator and multiply it out, but I think that this is close enough, right? The person is moving down, they are accelerating, and they're getting faster and faster and faster every second. Now, that's kind of the simple version. Let's look at these questions at the bottom, which are maybe a little bit more nuanced. And first of all, we have a force of gravity acting on this person, right? Gravity is a force that acts in the downward directions. Forces accelerate things, and basically the force is constant. That's why the acceleration is always constant. The force of gravity, we might know, is mg. If you want to be technical, m is the person's mass. That's not changing. G is 10 meters per second. That's not changing. So no, the force of gravity is constant on the person. Now, question B is kind of interesting, right? We're assuming in this table that there's no drag force balancing gravity. This is not true, right? So the person's speed is not going to approach infinity. No, the person's not going to reach an infinite speed. They are going to be slowed down eventually. I shouldn't say slowed down, but the acceleration is going to stop eventually due to the drag force. And eventually the person is going to reach terminal velocity. And terminal velocity is when the velocity has become constant. The person is no longer accelerating, and the reason for that is that the drag force would be exactly opposite of the force of gravity. So at that point, the person is going really fast. We call this terminal velocity, and it's about maybe 50 meters per second, which is about the same as 120 miles per hour, which is about the same as 190 kilometers per hour. Now, this is kind of measurements taken on a skydiver going belly down, right? If they were to, take themselves vertical and do a dive in a more pointed shape, they'd maybe be going faster. So drag is kind of complicated, right? But at this relatively high speed, the drag force is going to balance the force of gravity. The person's not going to accelerate forever. Now, another thing to note here in part D, when does the feeling of falling stop? And feeling, right, what we feel is acceleration and forces. We don't actually feel velocity. We don't actually feel speed. That feeling of falling is accelerating, right? So after some seconds, when you have reached terminal velocity, you're going really, 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 really fast, but you're not accelerating anymore. That feeling of falling is going to stop. And as you see, assuming no drag in the table, it takes 5 seconds to reach that terminal velocity of 50 meters per second. In the real world, there's a little drag. It might take a little longer, but that feeling of falling is only going to last a few seconds. Then you hit terminal velocity. You're still moving fast, but you're not going to feel it anymore because you're no longer accelerating. Your speed is constant. That's what terminal velocity means. The acceleration is terminated, and you're now at a constant velocity or speed.